Alright everyone, 2.10 synthetic division. Please write this in your table of contents. And so as we go in today's lesson, synthetic division, please write the skeleton notes as you see here. And so synthetic division is a coefficient based method of dividing polynomials when the solution to the divisor is an integer. And so what that means is, let's recap on when we have something like x plus 5 equals 0. The solution is when we simplify both sides, x equals -5, or in this case when we add 8 to both sides, x equals +8. -5 and +8 are both integers of those equations, so it's the solutions. And therefore we're going to use, the best way to use is synthetic division. If we recall from yesterday's notes, the divisor was 2x minus 3. The solution would have been 3/2, which is a rational number. It's all good and gravy, but it's best to have an integer. When we have integers, we use synthetic division. When we have non-integer numbers for those solutions, we use long division. And so now we're going to find the quotient of 3x cubed minus 2x squared minus 150 given x minus 4. And so quick annotations, quotient means we're dividing. And this is the dividend, this is the divisor. So just like before, step 1, we write the dividend if need any placeholders. So we go 3, 2, up. We don't have x to the first power, and so we got to rewrite it now as 3x cubed minus 2x squared plus 0x to the first power minus 150. That is our dividend. Our second step is to set the divisor equal to 0 and solve. So x minus 4 set to 0, and therefore the solution of that divisor is +4. Third step, set up synthetic division. And so long division, it's like going upwards, downwards I guess. But when it comes to synthetic division, the visual is going to look the opposite. It's going to be an L shape, where the solution to the divisor is going to be right here. And all of the coefficients from the highest degree to the lowest degree are only going to be written. So that's +3, not 3x cubed, +3, -2, +0, and -150. Again, I'm only using coefficients and constants when writing this. All right. Step 4 is to bring down the first term. So that +3, I just bring it down. That's it. So the first term, or the leading term of the quotient, is going to be +3. Step 5 is to multiply the first quotient by the divisor. So 4 times +3, that's +12. and then add the values. So when I add them together, -2 plus 12 is +10. And yes, I'm always going to add. Step 7 is to repeat steps 5 and 6 until solved. So what that means is 4 times 10 is +40. 0 plus 40 is +40. And yes, I'm adding every single time, no matter what. I'm adding every single time. 4 times 40 is +160, and -150 plus 160 is +10. All right. And so for here, I've now solved it. Step 8 is to rewrite with leading term being 1 degree less than the original leading term. What that means is that 3x cubed was our original leading term. This is still the coefficient 3, and one leading term, 1 degree less than 3x cubed would be x squared. So this becomes 3x squared. And everything else gets brought down. This gets +10 x to the first power. And this gets to be +40. And that +10 is the remainder. And so just like last class, plus 10 all over the divisor, which isn't 4, it's x minus 4. We ended in that polynomial. And so our quotient is 3x squared plus 10x to the first power plus 40 plus 10 over x minus 4. All right. And so there are two conclusions I want you to walk away with. If we have a remainder, then the divisor is not factorable by the dividend. If the quotient does not have a remainder, then the divisor is factorable by the dividend. Okay. And so as we're factoring things out and all this and gain that practice, this just proves what can be factorable and what cannot. So here are all the notes for the class. Please have them up and see you tomorrow.